All right, we're doing equivalent resistances, and here's problem one. So first thing that we need to know is R total. Well, it's in series, so it's going to be just the sum of all the different resistances. So it's going to be R1 plus R2 plus R3. So I got 6 ohms plus 2 ohms plus 4 ohms. Easy peasy, we got 12 ohms. All right. Current total. We're trying to figure that one out. So here I have volts, I have resistance, RT. Easy. So now I got 10 volts equals, that's V equals IR. Easy peasy. I times 12. So 10 over 12, we end up with, 5/6? But I'm going to use a decimal. 0.83 equals 0.83, but it's amps. That is the current. Now, let's see, what else did I do? Voltage for each resistor. So this is just going to be a series of V equals IR. Let's see, V1. So this is 6 ohms. So 0.83 amps times 6 ohms equals V1. So 0.83 times 6 times 6, 5. V1 equals 5. Great. Now, I know that these are proportional, so I can do like a quick method of this. So if this is 1/3 the resistance of 6 ohms, I can easily just go, 5 divided by 3, 1.6 ohms. And that's just to show off here. V2 is going to equal 0.83 amps because they all have the same current going through them, times a resistance of 2 ohms. All right, watch my number here. Okay. Sorry, I just realized I left my calculator up. So this is my guess from just my logic. Now, if I take 0.83, multiply it by 2, boom, we end up with essentially the same thing. So V2, 1.66 volts. Let's see, current for each resistor, all the currents are the same. So it's series. So we just need voltage V3 to make life easy. V1, V2, let's see, I, and resistance total. Great. So now I'm indicating where my stuff is. So V3 equals 0.83 amps times, what do we have, 4 ohms? Okay. So now 0.83 times 4. And if you want to check your math, we can just add up all our voltages together to make sure that VT equals V1 plus V2 plus V3. So here we have our voltage total is 10 volts. And I'm going to subtract V3, 3.32. I'm going to subtract V2, which is 1.66. And I'm going to subtract 5. We get some error, but VT equals 10, and it checks out. All right, that was easy. Let's go to number 2. Number 2 is our parallel equation. And just to show you, we always draw our stuff to begin with, whether it be a science class or if you have a problem at home, we draw. Kind of like current. It's drawn. Okay, we got 3 resistors, and then we have our power supply, and it's in parallel. Great. Easy. So I can see my pathway with all these different connections. Now I got to give it the business. So we got 20 volts here. This is resistor 3, R2, R1. Cool. All right. So now I need resistance total. So this is in parallel. So resistance total is going to be 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3, yada, yada, yada. We only have these three. Oh, and I didn't write down my resistances. I got 2 ohms. I got 4 ohms. And I got 6 ohms. So 1 over RT equals 1 over, 6 ohms plus 1 over 4 ohms plus 1 over 2 ohms. All right. Let's see. Let's turn these all into 24. Do I have to do 24? 12? I can do 12. Okay, 12. So 1 over RT equals 2 over 12 ohms plus 3 over 12 ohms. That should be 1/4. Plus 6 over 12 ohms. Common denominator. And now what we're going to do, 2 and 3 is 5 and 11. Okay, 11, 12 ohms. And 1 over RT. So we're going to divide that out. Whatever. RT equals 11/12. RT equals 0.916. Repeating. All right. Let's just check this. I've made a critical error right here. So here, what I ended up doing, I said 1 over RT equals 11 over 12 ohms. Now it becomes 11 times RT equals, because I'm cross multiplying, okay, and then I end up with 12 ohms. So now I got to multiply, or I got to divide out 11. And so I reverse this. So RT is 12 divided by 11, which ends up being 1.09 ohms. That is your total ohms. A lot more paperwork here. But now we've got this. Let's look at our problems. Okay. Current total. So our V equals IR will be tremendously helpful. 20 voltage equals current times the total resistance. Get that calculator game going. And we get 20 divided by 1.09, 18.35. Amps equals your current. That's your total current. Great. Let's go. Let's see. Voltage for each resistor, current for each resistor. So V1 is equal to V. This is a parallel circuit. So V1 is equal to V2, which is equal to V3, which is equal to VT. So it's equal to the same thing, 20 volts. Easy. But now we need our current. Okay, so IT equals I1 plus I2 plus I3. Okay. This is how we're going to check our work. But for resistor 1, so we have 20 volts equals I plus 6 ohms, or I times 6 ohms. So 20 divided by 6. Boom. 20 divided by 6. 3 1/3. So I1 equals 3 1/3 amps. I2 is going to be 20 volts equals I times 4 ohms. Okay, so I2 is going to be equal to 5 amps. And lastly, let's see. Yeah, I'm just a mess. I'm not showing you my stuff again. I do this kind of messy. That's why I use the stars for the first one. I should use stars over here too. But yeah, I2, I1. That's all the V's. That's our resistance total. Cool. 5 amps. And let's see. So 20 volts equals I3 and 2 ohms divided by 2. I3 equals 10 amps. And then IT, we should have 18.35. So 18.35 minus 10 minus 5 is 3.35, which is just about the last one. So our math checks out. We are good. 100% happy boys and girls. All right, let's call it on this one. I'll do more problems in subsequent videos.